The direct reduced iron or the sponge iron sectors form a significant link in the secondary steel sector, supplying close to half of the raw material inputs for the steel melting units. In a typical DRI plant, the rotary kiln is lined with refractory which protect the kiln shell when operated at high temperature. High alumina lining of 6 to 10 inches thickness, depending on the kiln module, is the most commonly found refractory material in the sector. The selection of the refractory is based on various factors like the maximum service temperature, refractoriness under load, pyrometric cone equivalent abrasion resistance, cold crushing strength, thermal conductivity, thermal shock resistance, resistance to carbon monoxide, etc. Radiation loss from kiln walls typically ranges from 8 to 10% of the total heat input. Disadvantages on using alumina lining include damages during accretion removal, gradual increase in shell temperature leading to energy loss, higher shell temperature due to high thermal conductivity leading to radiation loss. The energy-efficient replacement for high alumina low cement castables are mullite-based castables. Thermal conductivity of mullite-based castables is significantly low compared to high alumina castables. It helps the shell temperature to drop by about 50 to 80 degrees Celsius. This reduces radiation heat loss through the kiln shell. Heat losses in case of high alumina low cement castables is found to be approximately 5380 watt per square meter per Kelvin, whereas the same for mullite-based castables is 3796 watt per square meter per Kelvin. Using mullite-based castables in place of high alumina low cement castables can lead to a reduction of 14 to 16% in the skin temperature and around 25 to 30% in radiation heat loss from surface. Adoption of mullite-based lining in rotary kiln can lead to reduced specific fuel consumption, easy accretion removal causing less damages to lining, high abrasion resistance leading to improved life of kiln lining, very good hot modulus of rupture, low ferric oxide formation leading to improved behaviors under reducing conditions. Considering 100 tons per day DRI unit operating for 7,200 hours per year with a total of 396 meters square. Adoption of mullite-based lining will lead to saving of 180 to 200 tons of oil equivalent of energy, monetary savings of rupees 25 to 28 lakhs, and greenhouse gas emission reduction of 1,000 to 1,200 tons of carbon dioxide emissions on an annual basis in a unit. Other benefits include easy accretion removal, less damages to lining, high abrasion resistance, very good hot modulus of rupture, low ferric oxide, improved behaviors under reducing conditions. Mullite-based refractory typically costs between 40,000 to 45,000 rupees per metric ton. For a 100 TPD DRI plant, 180 metric ton of mullite-based refractory is required, which works out to be rupees 81 lakhs. This can be recovered within a period of 3 years. Refractory linings should be regularly monitored and undergo periodic maintenance. Accruals should be removed at regular intervals. Higher skin losses should be monitored and addressed immediately. One of the major limitations of the technology is its execution period, which requires overhauling of the project process, thereby leading to loss in production. With the right kind of knowledge dissemination, use of mullite-based refractory in rotary kilns of DRI units can bring in significant savings in terms of energy and also enhance the kiln life considerably. If implemented in 100 units, the technology can lead to a saving of 18 to 20,000 tons of oil equivalent of energy and around 1 lakh to 1,20,000 tons of carbon dioxide emissions annually.
As we all know, climate change is one of the biggest threats for today's civilization. MSME sector consumes substantial amount of energy and thereby there is a lot of GHG emissions. Latest technology in terms of energy efficiency can reduce this GHG emission and save substantial energy for the country. This will also help to mitigate climate change effects. Let's help the environment by reducing the energy consumption in the SME sector.